Hello and welcome to Truck Weight Analysis, configuring trucks to comply with state regulations. So this webinar is all about regulations. Compliance with US Federal Interstate and State road regulations, as well as provincial regulations in Canada, is essential when configuring trucks. It's important to bear in mind what the regulations are for your jurisdiction, but also for other jurisdictions if the vehicle will be operated in more than one state or province, or you're hoping to sell your trucks further afield, or indeed if you're already doing so. This webinar will cover how to configure efficient trucks that comply with regulations in your jurisdiction. It will include a live demo of the TruckScience Axle Weight Calculator using a Class 8 vehicle. Of course, compliance with road regulations is not our only concern. We need to comply with OEM ratings, including gross vehicle weight rating or GVWR, gross axle weight ratings, etc. We need to ensure that axle weight distribution supports steering and braking ability. For example, by ensuring that a significant portion of the total weight is carried on the front axle. We usually have a goal of maximizing payload capacity, and that's really what we're referring to when we talk about efficient trucks. We want to right-size the truck both to reduce capital cost and reduce fuel consumption. We want to avoid undue maintenance or rework, or indeed invalidating the vehicle warranty. And we need to be mindful of rollover stability by keeping the center of gravity as low as possible. Turning radius becomes important, for example, for a garbage truck that will need to turn in a residential area. And there are lots of other considerations too, including site infrastructure, driver needs, and internal standards stipulated by your own organization. But in general, these are some of the things we need to bear in mind when laying out a vehicle. However, the focus of today's webinar is regulations and the impact that those will have on your payload capacity. This webinar is going to examine how one truck fares across different states and provinces, some of the peculiarities between states and how they do, or in some cases do not, apply bridge law. It's going to include, as I said, a live demo of the axle weight calculator using a Class 8 vehicle. Lots of you have been attending these webinars for years or may already be using the tool and so are quite familiar with the interface. And some others of you I know are seeing it for the first time. So the pace might be a little slow for some, a little fast for others, but just try to get a general sense of what's going on. And if you have any questions, Paul is on hand to help with those. And we will, of course, always be willing and only glad to help you with a sample calculation on a one-to-one screen share like this. You'll also receive the recording and you'll be able to slow it down or speed it up indeed to watch it back. So don't worry if the pace is a little bit fast today. In order to compare how regulatory limits differ from one state or province to another, we're going to work through a truck weight analysis example. And to do that, I'm just going to jump screens here into a live demo. So just bear with me for a moment. Okay, so for the purpose of the demo then, I'm going to open a Kenworth T880 6x4 axle layout. And I'm just going to take this one with the long wheelbase. So in case this is the first time you're seeing the interface, if you just want to take a moment to look around, to orientate yourself, we always edit our layout from the left-hand side menus here. So we've got the chassis, body, equipment and payload, and indeed trailers. We won't be getting into those today, but as I said, we can do those in a separate session if anyone would like. You review compliance indicators down the bottom here. So we've got a dashboard where it indicates whether you're complying with both the OEM's limits and regulatory compliance. And it will, if you click in there, you can see which regulations are being applied at any point in time. There's a weight summary here or weight distribution table, and I'll get more into detail on that in just a moment. On the right-hand side, you can see the various views, including a bridge, center of gravity, and turning radius. But we'll start by editing this vehicle, the chassis. I'm just going to edit the wheelbase first. So I click on that wheelbase dimension in blue, go to 208. And I'm also going to edit the afterframe, which I can do by clicking on the afterframe dimension, or over here on the top left by digging into the dimensions of the truck and overriding the afterframe right here to 55.6. So we end up with a 29-inch rear overhang there. Next, we're going to edit the axle weight ratings. I'll click on the front axle, and I'm going to override the gross axle weight rating to 23,000 pounds. Because our focus here is regulations, we don't want to max out the manufacturer ratings too early, so I'll make them quite generous. I'm also going to change the tire width because that will affect how regulations are applied. I'm going to edit the gross axle weight rating on the rear axle up to 46,000. And the gross vehicle weight rating, or GVWR, up to 80,000 pounds. So you'll see that everything is still green here on both the federal common size and weight and the manufacturer's limits. I'm going to add a body. I'll choose a dump body and I'll search for this 16-foot body that I know is here. So as soon as I've added the body, the weights table fills up with a lot more information, including this maximum achievable payload figure here of 28,629. It's highlighted in blue. We will be referring back to that figure quite often as we go through the webinar, so do keep an eye on it. But right now it's 28,629 is the maximum achievable weight according to federal common size and weight regulations on this Kenworth T880 with this body in the position that it is in. You can also note here that we've got the permissibles for both the front and rear axles and the total permissible weight, and those are calculated as the lesser of the gross axle weight rating and the bridge or regulation limit. We've got rows here for the chassis weight, fuel and crew weight, and the body weight, and those are all added up to get the total unladen weight, in this case of 21,525 pounds. And you'll notice how that is distributed over quite evenly over the front and rear axles at this point. You also spot that we can't simply subtract the total unladen weight from the total permissible weight to get the payload, because in this case, the tandem axle is the limiting factor. It's already at 100% utilization, despite the fact that we are, I guess, underachieving in terms of the total vehicle capacity on payload. There is still unused capacity on this vehicle of 846 pounds when compared to the federal common size and weight limits. So in other words, the rear axle group has reached its limit before the gross vehicle weight rating or total bridge limit. The federal regulations are like a lowest common denominator for all the states. So you'll notice as we move this vehicle through different states now and apply their particular regulations, the payload will change. First, I'm just going to add a little body to cab gap here. So I click on the body on position, and I'm just going to increase the body cab to body clearance, or the CB, to 5 inches. Keep an eye on the payload figure. You'll notice it will change based on us moving more weight onto the rear axle. So as I add a cab to body clearance of 5 inches, the payload has been recalculated to 27,621 pounds. So the payload has dropped by about 1,000 pounds just with that little nudge of the body 5 inches away from the cab. Before we switch to New York State regulations, I want to just draw your attention to the front axle limit of 20,000, the rear axle limit of 34,000, and the total limit of 51,000. on the federal regulations. But let's switch to New York state roads here. So I just click into the settings, regulations applied. I'm going to clear the federal and add the New York state. You can add up to 5 sets of these regulations at once. You'll notice the permissible values have changed now. The 20,000 that we had on the front axle is increased to 22,400. We have 36 on the rear, and the 51 that we had on the total vehicle limit has moved up to 54,000 in New York State. So the maximum payload then, that figure highlighted in blue, has increased to 30,079 pounds. So we can achieve over 30,000 payload on New York State roads without a pusher axle. But let's try adding a pusher. So I'll click on the vehicle menu here, weights and axles, add pusher. And the payload has increased further to 32,264. So that's about another 2,000 pounds of payload. But of course, the gain is partly offset by the weight of the pusher axle itself. So you might ask yourself if it's worth adding a pusher at all in this case. We can examine the utilization row at the bottom here to see that the limiting factor is still that triaxle group of what is showing a utilization of 100%. But the total achievable weight on the vehicle of 55,500 is, we're using 99.3% of that. So you could argue that this is a well-balanced vehicle using all of the legal capacity of the triaxle group and practically all of the legal capacity of the entire vehicle. We are sometimes asked, what is the safe utilization score? The utilization score is just an indication of how close you are to either the state or provincial limits or the weight the manufacturer has rated the chassis at. So using 100% of what the manufacturer and your state or province has approved would seem safe to me. But if in doubt, and like everything else, you can always check with your chassis OEM. You can share the live calculation with them indeed, so that they can play around with it to help communicate some ideas back to you. So let's see how this truck fares on Delaware state roads now. Click into this dashboard settings, clear New York, and we'll add Delaware there. Delaware state roads. So the payload was 32,264 pounds, and it has jumped significantly to 42,785 pounds. The limiting factor has switched from the triaxle group to the tandem axle group. Axles 3 to 4, you'll see here, are now at 100%. To get even more payload on there, we could try moving more weight onto the pusher axle. So I'll simply click on this pusher axle here. I'll re-rate that up to 18,000. And I'm going to change this percentage of rear axle group weight carried to increase that up to 30%. Payload has jumped a further 5,000 pounds to 47,354. So we're getting really high weights now on a short wheelbase truck. This is because there's no bridge law on Delaware state roads. And if you're already familiar with the program, you may have noticed that the bridge view has disappeared here that I pointed out earlier from the right-hand side. And that is the reason for that there is no bridge law on Delaware state roads. You'll see that the rear axles are 3 and 4 are at 100% utilization, but we are underutilizing the front axle to the tune of about 40%, I guess. So let's experiment with loading the payload further towards the front by moving a CG forward. So you see, as I move the payload center of gravity towards the front, more weight is transferred from the rear axle group to the front axle group. And you can see we've got more payload still. We're up at 50,405 pounds now, and we are now finally using 100% of the total vehicle capacity. So simply a matter of loading the payload a little bit further towards the front, and we got a further 2,500 pounds payload there. Keep on the move. We'll move to an East Coast state now that's a bit different, and that's we'll try Georgia. So I'm going to clear again. And this is really just to give you a flavour of the, I guess, all of the various regulations and how applying them has such a big difference to payload capacity or permissible weights. Yeah, so we'll see now that we get a tip here. Georgia has some grandfathered rules, but not others. So we're looking at Georgia Interstate, but these rules do apply everywhere. So, oops, I just closed the tip there, but it did say that note that lift axles in Georgia do not increase the allowable bridge weight. To increase permissible axle weights in Georgia, try increasing the number of steering or driven axles. And this applies both on and off the interstate in Georgia. So our total permissible weight is comparatively low here at 51,000. That's the third row up from the bottom, total column on the right. And the payload has dropped to 28,125 pounds, which is really very similar to what we were getting on the Federal Interstate rules. But there are higher individual axle limits, for example, 40,680 here on the tandem. Because Georgia doesn't recognise the auxiliary axles, the pusher axle is not having an impact on the overall gross weight. Maybe the regulations were written before there were lifting axles. But maybe it makes sense now to just remove that pusher then in Georgia, because it is really at this point only adding to the weight of the vehicle. So we can just grab the scissors here to chop it off. And we notice that the payload has risen now from 28,125 to 29,475. So we're still getting a little more than we would under federal law. Let's try the truck out west. Let's go to Idaho. State roads in Idaho. Now you'll see we've got a permissible weight on the tandem axle of 37,800. This is the limit for any group of axles with a total distance under 13 feet. We're getting a payload of 34,650 now. Let's add the pusher back. And the payload drops to 29,525. So we're not getting a higher limit on the tridem axle group. You really need to know where you are. In some states, adding axles is the key. And in other states, you don't get more by adding more axles. It comes down to the overall distance between the front and the rear axles. So I mentioned we've got these different views here on the right-hand side. Weights, bridge, center of gravity, and turning circle. And because Idaho does have bridge law, that extra bridge icon appears here. So we'll just switch to the bridge view to examine the axle spread. Yeah, with the different views. So I was going to switch to the bridge view. And we can see here in the second to last row that the axle spacing or distance from axles 2 to 4 is 102 inches. We want to go to 13 feet on that axle spread to take advantage of the higher weight limits. So we'll find the axle 2 to 3 dimension by clicking on this vehicle axle 2 to 3. And I'm going to override that to 97 inches. so that the distance from axle 2 to 4 rounded will be 13 feet. So you can see here, the rounded dimension now is shot up to 13 feet. And the permissible from the tridem group increases from 37,800 to about 56,500 pounds there. So the axle spacing has a significant impact on the permissible weight on the 3 rear axles there. If I pop back to our weights view, you can see that the payload has increased to 39,646. I'm throwing a lot of payload figures out here, but it's just interesting, I guess, to see how it varies so much with small tweaks to your layout. You'll remember that we had changed the center of gravity of the payload. So I'm going to load further towards the front, but I'm just going to set that back to an evenly distributed load with the center of gravity at the center point along the load deck. The payload has dropped to 36,000 now, but we're not maxing out the overall capacity because you can see in the unused capacity row down here, total of 5,628 pounds of unused capacity. So we're going to increase the wheelbase and opt for a longer body. I'll just increase the wheelbase up to 241 inches. Remove this body. And add another one. And you'll see now we've got 42,421 pounds of payload. Might just put that cab gap back in there. And we're down to 41,000. So let's see what happens when we move the first pusher axle back and add a second one in front. So I'm just going to click on the chassis here to change that spacing again back to 48 inches. And while I'm here, I'll add a pusher axle, a second pusher. So you'll see that the limiting factor then, or the 100% utilization now, is of that quad axle group, or axles 2 to 5. If we go back to the bridge view, you see that the distance is rounded to 12 feet. And again, we want to get that up to 13 feet. So we'll increase the spacing between axles 4 and 5. Oops, ran into the wrong place here. We just increase that by less than 1 inch in this case. So I'm just going to push it up to 54 inches. And our payload has jumped up to 42,623. So sometimes it's really down to just the difference of 1 inch or 2 here or there. And now we can see again that we are using the full capacity of the vehicle at 100%. So as I said, in some states you get more weight on by adding more axles, and in others it's very much down to the overall distance between the front and rear axles. So it really is important to know where you are. So let's take this truck across the border now into Washington State. And the total bridge limit fell, that permissible value right here, the total bridge limit has fallen from 67,250 down to 61,500 in Washington State. The pusher axle permissibles were reduced from, you see here, pusher 2 and pusher 3, reduced from 13,000 to 11,600. Because in Washington, you've got 500 pounds per inch of tire width on 2 tire axles. If we check the tire width, we can see that it's 11.6 inches. Right here. And our payload is down to 36,873 pounds, highlighted in blue there. Lastly, we're going into the last US state of Minnesota. Oh, we're going to one more after that, I think. So I'll clear these. I'm going to Minnesota. I hope I've managed to touch on some states of the participants in the webinar. We've been going on a real tour. So now there's no change to the payload because, again, the federal bridge laws are applied. So let's see how Minnesota compares to Iowa. I had said it was the last state, not quite yet. And before we do that, I'm just going to lock the payload at 36,873. And now I'll add regulations for Iowa without removing the regulations for Minnesota. This vehicle is now legal in Minnesota, as indicated by the green tick, but not in Iowa, as indicated by the red cross. And we can see that the reason for that is that the permissible in Iowa is down to 57,500, whereas the gross weight of this vehicle, as we had achieved in Minnesota, was 61,500. So we're overloaded there on the total vehicle capacity by 7% or £4,000. Grab Kenworth T880 6x4. Here it was. We just very quickly show this vehicle in Ontario. Just take this one down to 208. So it's about 55. Add a dump body. Position it five inches away. And I want to switch from Iowa and Minnesota to Ontario provincial spiff. And I will also just change the measurement system to metric for this one. Okay, I think that's working out a bit better. I wanted to show you some tips from Ontario. So if I were to extend this wheelbase, I think significantly, it will prompt a tip in Ontario. Oh, I know what I wanted to show you. If I add a pusher axle here, so there's a tip here about the vehicle currently validated against the designated truck 3 or truck 5, and what you can do to take advantage of those, basically. Obviously, this body is a very mis-sized body for this truck. Let me grab a slightly different one. I'm not going to go into too much detail here. If I take the body a little bit further back, we're getting a payload of about 6,000 kilos there, but we have an issue here on the Ontario spiff, and you'll see there's a dimension there highlighted in red. We've obviously got a problem with that one. The other thing that I wanted to show you was that it will flag if you try to add a second pusher to this, that second pusher is not actually Allowed in Ontario, a maximum of one pusher axle is permitted on trucks with a 6x4 axle layout under regulations for Ontario. So it will stop you doing some things you should not be trying. Remove that one. And let's just fix this. There's a problem here with this dimension. And I'm not sure if it's too small or too big. Let's just try it. Let's try something a bit smaller then. No, let me see. Let's go a bit even bigger still. Okay, there we go. So it is forcing me to create the distance between that axle 2 and 3, and it's these tips that are helping me to understand what's going wrong here. Is this tool and all of the scenarios produced linked to some sort of drive cycle analysis to understand fuel consumption at a truck and fleet level? The answer to that is no, not in this tool. We are primarily concerned here with weight analysis. So when we say the truck is efficient, in this case, we mean it can get a lot of payload on there, but we are not calculating fuel consumption over your routes or anything like that. So I hope that answers your question. The next one, are the weights with the various trucks in your catalogs include alternative powertrains, for example, battery, FC, etc.? So we add vehicles to our library on demand. You can request us to add any vehicle that you need. If I just click into this chassis here, you see that there is an energy source tab that I didn't touch on, as well as a crew tab, where you can specify the weight of your crew members, etc. The energy source, you can choose from diesel, battery electric, etc., etc. And depending on what you choose there, the regulations will reflect, for instance, extra weight allowance for battery electric. So let's just switch this one to battery electric quickly. Obviously, that's not something that Ontario is going to give you any extra weight for, but I think, let me try this. You might get some in California. Let's try. Oh, here we go. Battery-powered vehicles qualify for a 907 kilogram weight increase, which I presume is a 2,000 pound weight increase in imperial measurement. If I switch that back, that tip would generally be shown in imperial, but I've switched to metric, obviously, for Ontario. So let's move along. Okay, thanks. Do you know any literature which can take into account the dynamic sloshing of liquids for calculations of axle weights? I don't know of any literature offhand. This tool also does not do dynamic calculations of liquids sloshing around. You can add a tank body here. I'll quickly show you that. Let's see. Oops. I don't know what size of a thing. Okay, it's not a great size, but it'll do for what we need to talk about. So you can add DXF drawings of your own tank bodies or these kind of templates, TruckScience templates. We can change the body length, payload here on the left-hand side. I can switch to what we call a detailed payload as opposed to an evenly distributed water level load. I'm going on to detailed payload. And I'm just going to add like a tank compartment here. And if I click into that, and I'll keep this short and sweet, but I can say that my payload is specified as in terms of volume instead of weight. And then I can add units of measure, for instance, gallon and 1,000 gallons and this many pounds per gallon, etc., etc. And it will calculate the weight of your volumetric payload. Okay, next. Can we see a demo with a battle chassis since they have a unique battery rack? I am conscious that we're running out of time too. So I'll just quickly show you a battle chassis, but David, if you'd like to take that one offline, I'm going to show you how you can sign up for a one-on-one session in a moment, and if anyone else has a kind of a specific question, then we can deal with that too. So here is the Battle Motors chassis. Let's see. Okay, so this spec sheet that we've used to add this is missing chassis weights front and rear. And I'm not going to get into setting up that vehicle now because I'm conscious of time and we want to be done in 4 minutes time. So David, if you want to reach out directly, we can set up a one-on-one, 30 minutes or so where we work through an example on this one for you. Okay, anything else? Do you have refuse bodies? Yes, we do. Let's add a refuse body to this one if we can. So again, you can use a truck template, refuse body, or many of the refuse body manufacturers have added their products to the TruckScience library, but they make them available only to authorized users. So if there's a particular brand you need and you have a relationship with that body manufacturer and you think that they may be open to allowing you to see their bodies in the tool, please just reach out to us and we can seek their approval to allow you to see their bodies in the list here. I'll just show you a template for now. I can figure the math out. I was just curious, it was part of the software. Okay, thank you. Okay, so that's a sample refuse body. If that might be it for the questions. Okay, let me just switch then back to my presentation for a moment. Okay, so just to wrap up then, obviously we traveled through lots of states and up into Canada. We went from New York to Delaware, Georgia, Idaho, Washington, Minnesota, Iowa, and lastly on up to Ontario. And our maximum payload fluctuated quite wildly between 27,500 pounds of payload up to over 50,000. So I guess that just illustrates the point that it is very important to know where the truck is going to be operated and what the regulations are and how they're applied based on tire width, distance between axles, the presence of pusher axles, whether or not they're allowed, and many other factors. There's quite a lot going on, but can we ever really say how much a truck can carry if we are not first asking where it's going to be operated? As I said, I've covered a lot in a short time today, but if you would like to set up a personalized demo for yourself or your colleagues who weren't able to attend today, I'd be happy to do that for you. You can do that right away now by choosing a time on my calendar. So if you go to calendly.com/Sorcha-O'Grady, you can choose a time that will be mutually acceptable to both of us. I look forward to meeting you on a one-to-one screen share. If you'd like to find out more about TruckScience, you can take a look at our page on NTA's website, nta.com/TruckScience. You'll find lots of videos and testimonials, explainer videos, webinar recordings, etc. on our own website, which is truckscience.com. And we'll be, our next two shows, I believe, are back in Indy. So we'll be in Indy in February for the water and wastewater equipment, treatment and transport show. And then we'll be back in March to our favorite show of them all, NTA's Work Truck Week. If you're not already using TruckScience, please help yourself to a free trial from our homepage, truckscience.com. And NTA members who add their membership details to their trial will have their trial automatically extended from 7 to 30 days and will also qualify for a discount of $100 at checkout from off a year's subscription. So that's all for today. Thanks for your patience with our communications issues. I'm going to end this webinar in a moment. Before you go, please rate the webinar and leave any comments or questions. If you'd like to receive any further information, just leave a question or you can leave a comment in your rating. If you want to find any information about pricing in particular, please just indicate how many users you are looking for. That's it. hope to see you back in Indy in March at the latest. Thank you for joining us, and goodbye.